In this video I'm going to be hooking all these batteries together in series. They're nominal 18 volts each. I've got 6 of them, so that's going to give me about 120 volts. So this is high voltage DC is dangerous. Just because it's not coming out of a socket doesn't mean you can't do some serious harm. Don't do this yourself, blah blah blah, usual disclaimer thing. If you do and you hurt yourself, well, I don't know what to say. Shouldn't have done it. You're an idiot for not listening. That it's a little bit dangerous. Alright, so I got a bunch of cordless tool batteries here all hooked up in series. As you can see, if we check that, there's 123 volts DC here. Now, the reason for this is I'm going to show you a little something. Alright, so here I've got this light socket here. I don't have any incandescent bulbs to plug in there, but that's DC, and here is a regular compact fluorescent light bulb. So you know what, actually I'm going to go get some more alligator clips, and I'm going to put a meter in there just to monitor the current draw, just for fun. So this is I'm going to plug this in, and we're going to power it up off just because it's not coming out of
through the whole mess.
socket
Hopefully
doesn't
you can
mean
see
you can't
I've
do some
got
serious harm. Don't do this
current
yourself,
here.
blah blah blah, usual
Small one
disclaimer
will
thing.
be
If you do and you hurt
the,
yourself, well,
the voltage.
I don't know
There's
what
the
to
light
say.
bulb hooked up.
Shouldn't have done it. You're an idiot for
So we'll
not listening.
Power.
That it's a little bit
And
dangerous.
lo and behold, there we go. It lights up. So it's 122.5 volts DC across that bulb. Of course, the incandescent bulb will light up as well. But you know, why does the fluorescent bulb light up? It needs a few thousand volts, so that means there has to be a transformer in there to step the voltage up. And you know, transformers, they don't work off of DC, and that's essentially, you know, what the ballast is. So if you hooked up a conventional you know, fluorescent ballast, it would not work either. Now, just for fun, let's give this LED bulb a shot and see if it does anything. Look at that. This one happens to light up, and oh, let's just see how much current that was drawing. Interesting. It's actually drawing a bit more than what the fluorescent was. So let's unscrew that, and I'm going to try one more LED bulb. And look at that. One lights up nicely too. So why is it that we can run these light bulbs that are designed for AC off of DC as well? Well, let's take a look inside the compact fluorescent. I'll clean this up and let's crack it open. Alright, so I just took it over to the bench vise and took the hacksaw and cut all the way around. Unfortunately, you can't pull it out very far because the leads are not long enough, so I snipped both leads, but you know, there's nothing really in the base down the bottom. So we've got here a that'll be a fuse there, inline fuse, or well, not inline, but you know, a fuse or a fusible resistor. In fact, let's actually cut that right open and just check. So that is actually a resistor in there. Assumed it would have been fusible, but I'm not completely sure. So that'll be to probably limit the inrush current as well as provide some protection there. Alright, anyways, it goes in here, and well, see if I can get that board off the bulb. I want to save the, don't want to cut these leads. I want to keep them as long as possible because I actually want to use this bulb for something. Alright, so I just unwrapped those. Those are actually, these leads here are just wrapped right around these pins on this board. If we take a look here, flip it over, and what do we got? We've got 1, 2, 3, 4, well, there's 5, but we've got
four diodes, and here was our power coming in, and the other wire. So power comes in, and it is immediately rectified. And there's our filter cap right there. So the first thing that these electronic ballasts do is we're converting it to DC. So this is operates similar, I guess you could say, to some of these cheapy switch mode power supplies. I mean, there's no need for isolation or anything. There you go. And where is it? There's the single transistor. Oh no, there's two transistors. I have pulled one of these apart and checked those transistors. They're a high voltage transistor that I read through the data sheet, or well, skimmed through it, and it did list them as being designed specifically for this purpose. They were, I shouldn't say they were designed specifically, but they did say, the manufacturer did claim that they were well suited to be used in things like compact fluorescent lights. And that's where the that fusible resistor was. That lead sticking off, pointing down to the right. And you see it's actually marked F1 for fuse 1. So yeah, there's not a lot of room in these. You've got a little toroidal core there that's got some windings on it, and that'll be to set up an oscillator. So then with some clever part selection and a certain amount of inductance in that, you can then limit the current. So when you fire up the bulb and there's no current flowing through the bulb, it'll boost the voltage up high enough to start the bulb. You get that starting voltage, but then when the current starts to flow through it, this adapter is just not capable of putting out that much current, and the voltage will drop down. It's a much nicer method of doing it, I think, than the original old ballasts that used neon bulbs. So now, without actually ripping this bulb apart, I know that there's going to be a fairly decent driver in there. There'll be an actual switch mode driver. The cheap bulbs that you can find on eBay and on Amazon that come from these Chinese sellers, most of those are just a simple resistive dropper, and that will those depend on AC voltage coming in order for the current limiting circuitry to work. In fact, if you feed them DC, nothing happens at all. The capacitor will charge up, and that's it. You will get a tiny bit of leakage current going through your the bleeder resistor across the dropper capacitor, but yeah, they're not going to come on like this did. And the other one was Phillips bulb, which I expected would have a bit more circuitry, and this is a non-dimmable bulb. The Phillips bulb is dimmable, and I've got one of each of those to rip apart. And of course, with any consumer bulbs, I mean, these are relatively new CFLs. I don't have any intention of buying more at this point. Just using up what I have and switching over to LEDs as they burn out. But you'll notice that they didn't really leave a lot of room. This is only 200 volt rated cap, and this little red guy right here is rated 250 volts, so not, that's pushing it. And I just figured somebody is probably going to be going, well, can I just take this bulb and hook the bulb up directly across the batteries? What if I put some more in there and had a higher voltage? Would that work? No, you can't do that. Fluorescent bulbs do not have the ability to regulate the current flowing through them. You push them up to the voltage they need to be lit, and they will simply self-destruct. They require a ballast to limit the current. So ballast doesn't just up the voltage, it provides the higher voltage and it limits the current flowing through the bulb. Otherwise they would just blow up on their own. Plug it in, boom, gone. One bright flash of light, that's it. Alright, well that's it for this video. Till next time. Alright, let's just have some fun here with this. Smoking. Obviously hit the current limit on this power supply. Well, there we go. That's the worst fusible resistor I've seen ever.